Hello guys. So in this lecture we are going to talk about the decrease key function, or we also say that change key function. Okay. So what we are going to do by using this function is that we are going to change the value of a particular node. Okay. So first we'll talk about the min heap. Okay. And then we will talk about the max heap. Okay. Now we already know that in a min heap, the minimum value is at the top, right? Yeah. So in a min heap, minimum value is at the topmost position, and in a max heap, maximum value is at the topmost position. Okay, maximum value is at the topmost position. Now, one thing that you guys should know is that uh, so in the min heap, we are going to talk about decreasing the value because minimum value is at the top. Okay, so if there is a minimum value in the lower levels, then it is going to change the structure of the node, structure of the min heap, right? So in that case, we are going to talk about the decrease key function in the min heap. And in the case of max heap, we are going to talk about maximizing the value. Okay, because the maximum value is at the top. So if the maximum value is at some lower levels, then the structure of the max heap is going to change, right? So in that case, we are going to talk about the increasing key, and in this case, we are going to talk about decreasing key. Okay, so let me write it: decreasing key. And here we'll talk about increasing key. Okay, increasing key. Okay, but before these functions, we are going to look at the program for the max heapify function. Okay, max heapify function, and it is just similar to the min heapify function. So if you know min heapify function, uh, I've already told you the implementation of max heapify function in the previous lecture. uh, so if you just know how a min heapify function works, okay, there is no change in the max heapify function. Okay, so let me write you the program code so that you can understand what I'm talking about. So let's say, uh, yeah, so I'll create another program, maxheapify. Okay, heapify.cpp. Okay, now I'll copy the previous code first. Okay, so that I don't have to do much work. Yeah, so I already have done some work. What I'll do here is that I'll just write the maxheapify function. Okay, so that you guys know how it works. Okay, yeah, so it is already written. It is already written. Okay, so what happened? Okay, now will do dry run of this particular code. Okay, this is the max cpf function. So we'll choose left, we'll choose right index, and we'll have a index of the largest element. Then we'll compare, and each time we get a violation, we are going to fix that violation. Okay, but here we can only check for one particular violation if the violation is at the root only. Okay, but if there are multiple violations, then we have to use the build heap function. Okay, that we'll talk about later on in the lecture itself. Till then we'll talk about this. Okay, so yeah, so this is what the max heap I've created. So let's say this is a max heap. Okay, max heap has arr 0 as 30, arr 1 as 40, arr 2 as 35, arr 3 as 25, and 36. So let me write it down. Okay, 30, 40, 35, 25, and 36. Okay, so the arr looks something like this. Okay, okay, so 30, 40, 35, 25, and 36. Initially it looks something like this: 0, 1, 2, 3, and 4. Okay, so according to arr, the binary heap will look something like this. Okay, so let's say this is the structure: 0, 1, 2, 3, and 4. Okay, so this will have index 0, this will have index 1, this will have index 2, this node will have index 3, and this node will have index 4. Okay, now talking about the values. So 0 node has value 30, right? So 30. Then the first index has value 40, second index has value 35, third index has value 25, and fourth index has value 36. Now this is the max heap. We have to fix the heap from the index 0, right? At index 0 there should be 40 and not 30, okay? Comparing these three, okay? So there should be 40 and then there should be 36 in place of in index 1, and 30 should be at index 4, okay? Now when we use maxheapify function, okay? Maxheapify, we call maxheapify and then we give it an index, okay? So let's suppose we want to fix 0th index in this case, so we'll give it index 0, okay? Now what happens, let's see, okay? Let me take you to the program code, okay? So this is the program, okay? Wait, okay? So okay, so yeah, so what we'll do, we'll pass it an index I, okay? Then we'll find the left of it, then we'll find the right of it, and then we choose a variable largest to store the this particular index only, okay? I that we have passed, and then we'll compare left if left is less than size, and ARR of left is greater than ARR of largest, and if R right is less than size, and you know we will perform these many operations, okay? Let's get back and let's see what we are talking about, okay? So now what we'll do for maxheapify 0, okay, let's say we have called maxheapify of 0. So what we'll do, we'll find left and right first, okay? Let me move it a little bit, okay? So what we are going to do, let's see, okay? So let's say left of index 0, this index we have passed, right? So left function will give us the left of it, which is 1. Index 1 is the left, right, and index 2 is the right, so right will have value 2, okay? And then in largest we are going to store the index itself, so we have passed 0, so 0 will be stored in the largest. Now we'll compare the size, okay? So the size is initially 5, right? 1 2 3 4 5, there are 5 elements in the heap, so the size is going to be 5, and the capacity is also going to be 5, but capacity is not needed, okay? Now we'll compare, okay, whether left is less than size, okay? Yeah, left is less than size, right? 1 is less than 5, and now we'll compare ARR of parent of I, sorry, ARR of L is great, whether ARR of L is greater than ARR of largest. So ARR of L is 1, okay? Whether this condition is true or not, okay? So ARR of largest is 0, right? Value of largest is 0. So let's compare, okay? So the value of ARR of 1 is 40, okay? Whether 40 is greater than 30, ARR of 0 is 30, right? ARR of 0 is 30, ARR of 1 is 40. So yeah, this condition is holds true as well, and this condition holds true as well. So what we are going to do in the first case, okay? So what we are going to do, largest becomes L, okay? Move back, okay? So largest gets changed, it becomes left, okay? Left is 1, right? Left is 1, so it becomes 1. Now we'll again check, we'll again check we'll check whether R is less than size. R is 2, okay, which is going to be less than size, right? And ARR of R, okay, which is ARR of 2, whether it is ARR of greater than ARR of 1, because now largest has become 1, right? Whether ARR of R is greater than ARR of largest, and largest is changed since it is 1, so we are going to put 1 here. So R is less than size, this condition is true because R is 2 and it is less than 5 itself, okay? And then we'll check this, okay? So ARR of 2 is nothing but 35, you can check it from here, this is the ARR area, okay? So 35, whether 35 is greater than 40, sorry, whether 35 is greater than 40, we'll check for this condition because the value is not changed till now, okay? So index 1 has the value 40 itself. So whether this condition is true, no, this condition is not true. So the statement within this if statement won't be executed, this largest equals to R, the value is not changed. And now the third condition, okay, if largest does not equals to I, okay, largest does not equals to I, okay, whether this is the case, largest is 1, which is not equals to 0, right? I was passed as 0 initially, right? This is what I is, okay? So yeah, it is not equals to I. So what we'll do, we will swap ARR of I, okay, wait, okay. So we are going to swap ARR of I with ARR of largest, okay? Yeah, so this is what we are going to do. So I is nothing but 0, okay, ARR of 0, with ARR of largest has become 1 now. Okay, so we will swap these two values. Okay, so let's swap. Okay, so 0 has 30, 1 has 40, so 30 will go at the place of 40 and 40 will come at the place of 30. So let's change this. Okay, let's erase. Okay, yeah, so now put the value again. Okay, so 40 comes here and 30 goes at the first index. Okay, now erase it all. Okay, so that we can again perform what we want to. Okay, and now after swapping, I becomes parent of I becomes parent of I. Okay, uh, if I'm right, or let's say, sorry. So what we'll do, not I becomes parent of I, but we'll call for maxheapify function for the largest index. Largest has now become 1, so we'll call maxheapify of 1. Okay, now in this case we have passed 1 here, so I will become 1. Okay, now what will be left of 1, 1 index is 3. Okay, so left is 3. Okay, let me erase it and let me write it with different. Okay, so L becomes 3 and right is 4, right? Of index 1 has the right index 4. Okay, so right will be 4. Okay, now we again check for the two conditions that we have checked previously. So what we'll do is that whether L is less than size. Okay, L is 3, which is obviously size is 5, right? Size is 5, so L is less than 5. This condition holds true. Now we'll check if ARR of L is which is ARR of 3, right, is greater than ARR of largest. Okay, so largest is 1 only. Okay, this largest is 1 only, so whether it is greater than ARR of 1. Okay, we'll check for this. So ARR of 3 is what? Let me go back. We don't look at the heap because we haven't fixed this. Okay, so we'll check at the array. ARR of 3 is 25 and ARR of 1 is 30. Okay, so ARR of 3 is 25 and ARR of 1 is 30. So whether this condition holds true? No, 25 is not greater than 30, right? So now we'll check for the another condition, the second condition. Okay, whether R is less than size. Okay, R is 4, which is obviously less than 5. Okay, so this condition holds true. Now we'll check another condition, which is ARR of R is 4, right, is greater than ARR of largest is 1. Okay, let's check. Okay, so ARR of 4 is nothing but let's move back to the array. ARR of 4 is 36. Okay, so whether 36 is greater than 30, ARR of 1 has 30, right? You can see this. Okay, so yeah, this is true. So what we'll do, we'll change the largest. Okay, largest becomes ARR of largest becomes R. Okay, so R is 4 now, so largest becomes 4. So let's cancel this. So new value of largest becomes 4. Okay, now if largest does not equal to I, so I we have passed as 1 here now. Okay, and largest has become 4, which and 4 is not equals to 1, right? So what we are going to do, we are going to swap. What we are going to swap? ARR of I, which is 1, and ARR of largest. Okay, so largest is 4 now, so we'll swap these two. Okay, so let's swap them. Okay, so ARR of 1 and ARR of 4. 36 come at the first index and 30 goes to the place of 36. Okay, so let's erase it. Okay, now 36 comes here and 30 goes to the last fourth index. Okay, now we will call again for the maxheapify of largest. Okay, we'll call maxheapify of 4. Okay, but now in this case we'll get left as 2 into 4 plus 1. Okay, and we'll get right as 2 into 4 plus 2. Okay, because this is the formula for finding left and right index. Okay, and this is 9 and this is 10. Okay, both of which 9 comma 10 are greater than the size of the heap. Okay, so if both of them are greater than the size of the heap, then the first the two if conditions won't execute. The statement within the two if condition won't execute, due to which the value of largest do not change. Okay, value of largest do not change, and if the value of largest do not change here, okay, if the value of largest do not change, maxheapify function and swap will not take place. Okay, so the function gets terminated, and this is what we get as the heap. Okay, now changing the value within the heap. Okay, let's change the value. So at the 0th index we have 40 now. Okay, so let's erase it. Okay, let's erase. Okay, so at the 0th index we have 40 now. Okay, 40. Then at the first index we have different value. At the second index we have 35 only. At the third index we have 25 only, and at the fourth index we have a different value as well. Okay, yeah. So now let's fix it. At the first index we have 36, so 36 come to the place of index 1, and at the fourth index we have 30. Okay, yeah. So this is what a max heap, this is how a max heap is fixed using the maxheapify function. Okay, so what we get as the output, we get as the output 40, 36, 35, uh, 25 and 30. Okay, let's check whether we are getting this output if on running the code or not. Okay, we have called for maxheapify function, right? We have called for maxheapify function, and now we are again trying to print the maxheap. So the order that we should get is this: 40, 36, 35, 25 and 30. Let's see. Yeah, so we are getting 40, 36, 35, 25 and 30, which is the correct output. Okay, according to our dry run. Okay, now what we are going to do is that, let's say, we are going to talk about the uh, decrease key function. Okay, how do we in the case of min heap. Okay, for min heap we are going to call for decrease key function, and it has a very important role. Okay, so we are going to call about decrease key function. Okay, what it will do, it will do nothing, but it will decrease value at a particular index. So let's suppose this is a heap. Okay, let's suppose this is a six sized heap. Okay, uh, this is a min heap of size 6. Okay, so the minimum value will be at the top, right? So this will be some minimum value. Okay, minimum value. Now let's say we use the decrease key function and we change the key of this particular index. Okay, to some lower value. Let's say now this becomes the minimum value. Okay, after using decrease key function, this the value of this node becomes the minimum value. Okay, so we'll have to fix the heap, right? So this is what it is used for, to decrease the value of a particular node. Okay, it is either called key, either it can be called as value as well. Okay, so for this function we'll use decrease key function. Now how we will do this? So what is going to be the function? So this is going to be a void function. Okay, so void. Okay, decrease key. Okay, decrease key. And then what we are going to do, we are going to pass nothing to it. Okay, so what we are going to, okay, so we must pass something, because we have to change the value at a particular index, right? So to change the value at a particular index, what we'll have to do is to decrease the value. Okay, so yeah, so we'll pass at some index in, let's say idx is the index of which we have to decrease the value. So this is index 0, this is index 1, this is index 2, this is index 3, this is index 4, and this is index 5. Okay, now these are the indexes. So we have to, let's say, decrease the value at the given index idx. Okay, this is the given index to us, and we have to change the value at this particular index, and we are given the value. Okay, now what we are going to do, simply we are going to change the value this way: arr of idx becomes value. Okay, now let's say this has become the minimum value now. Okay, so in order to bring the value to the top, now what we are going to do, we are going to use we are going to do some operations. Okay, so what we are going to do is that while I does not equals to 0, sorry, and ar, so it should be idx and not I. Okay, because idx is passed as the index, right? So while idx is not equals to 0 and ar r of idx, okay, is lesser than arr of parent of idx. Okay, let me move it a little bit. Okay, so we'll have to erase this now. Okay, because it is not useful now. Okay, yeah, so and it is less than arr of parent of idx. What we are going to do, we are going to swap arr of idx, okay, and arr of parent of idx. Okay, idx. Okay, and then what we are going to do, okay, erase this because it should look like a function, right? Idx, yeah. And then idx becomes parent of idx. Now let me tell you what I'm trying to say. Okay, so while loop closes, okay, and this function closes. Now let's take an example. Okay, so we have a heap. Okay, let's say the size of the heap is 5. Okay, so this is the heap that we have. Okay, okay. Now indexing would be something like this: I equals to 0, I equals to 1, I equals to 2, I equals to 3, I equals to 4. Okay, now let's say uh, we have to, you know, we have to decrease the value of this particular index. Okay, I equals to 4. Then what will happen? Since it is a min heap, let's say the value of this node after decreasing becomes the minimum. Okay, so it should move up to the top, right? And the top value should go somewhere below. So what happens is that after we call decrease key, we will also have to use another function which is extract minimum. Okay, extract minimum in order to sorry, not extract minimum actually, to bring it to the top. We This while loop will work. Okay, first we are going to decrease the value of that particular index, and then this while loop brings the value to its correct position. It might not be top, it might not be the minimum value, it might be a value which comes at the level, this level. Okay, second level. So in that case, while loop will bring it to the level it belongs to. Okay, now let's look at the example. So we have a min heap like this. Okay, let's say the minimum value is -3, and okay, let me change the color. Okay, yeah. So let's say the minimum value is 3. Let's say, okay, -3, and let's say here the value is 5, here the value is 7, here the value is 11, and here the value is 9. Okay, now let's say we erase this for now. Okay, let's say we decrease the value at index I equals to 4. Okay, and we change it to, let's say we change it to -5. Okay, now -5 has become the smallest. Okay, earlier it was -3 which was smallest, but now -5 is the smallest, and since it is a min heap, -5 should be at the index 0. Okay, so what happens according to this function, how it works? Okay, so decrease key, we are going to pass the index is 4. Okay, so we will call decrease key we'll pass it index was 4. Okay, and we'll pass it value is -5, right? Earlier it was having the value 11. So let me tell you from the start how it works. Okay, so let's suppose it has value 11 only till now. Okay, so 11 value. Now when we call this function, what happens is that so first of all, let's create the array also. Okay, yeah, so this is the array: 1, 2, 3, and 4, and 5. Okay, so let's suppose 0, 1, 2, 3, 5 are the indexes, and -3 is at the start, then 5, then 7, then 9, then 11. Okay, earlier this is the condition. Okay, this is the heap that we have. Now we, okay, this is not 5 actually, this is 4. Okay, yeah. So we want to change the value of index 4. That's what we have passed in the place of idx, and in the place of value we have passed the new value. So earlier it was having value 11, now it will have value -5. Okay, and since the value is changed here, -5 is the smallest in the heap, and it should go up, right? It should be at the top. So what happens is that we change the value first in the index. Okay, so this is changed. Okay, so arr of idx, what arr of idx mean? Arr of 4. Okay, and it becomes equals to value is -5. Okay, so -5 is put here. Okay, okay, so -5 is put here, and yeah, this way -5. Okay, this is -5, and now what happens is that this while loop will work. Okay, while idx is not equals to 0, idx is 4, right? In this case idx is 4, and value is -5. Okay, equals to -5. Okay, now since idx is not equals to 0, so first condition satisfies. Okay, we'll check for second condition, whether arr of idx is 4, is less than arr of parent of idx. So parent of 4 because idx is 4, right? Parent of 4 is 1. Index 1 is the parent of index 4 and index 3, right? So index 1. So whether this condition holds true or not. Okay, so arr of 4 is nothing but minus 5 now. We'll check in the array. Okay, is whether minus 5 is less than arr of 1. Arr of 1 is 5. Okay, yeah, so this condition holds true, right? So what happens is that we swap the value at these two indexes. So let's swap these values. So arr of 1, 5 goes to the fourth index and minus 5 comes to the first index. Okay, so let's erase this. Oh, we did a mistake here. So minus 5 goes here and 5 comes to the index, last index. Okay, now what happens is that idx becomes parent of idx. So idx will now become, idx was 4 earlier, now it becomes the parent of idx. So parent of idx is 1. Okay, 1 is the parent of index 4, right? So idx now becomes 1. Okay, now we again check. Okay, what we are going to check, whether idx is not equal to 0. Yeah, idx is 1, which is not equal to 0. Now the second condition, so arr of idx, arr of 1, whether arr of 1 is less than arr of parent of idx. Parent of 1 and parent of 2 index is parent is 0. Okay, so whether this is true or not. So this is minus 5. Okay, you can see here. Okay, in the array, this is not yet fixed. Okay, so minus 5, whether minus 5 is less than minus 3, this is true, right? So we are going to again swap. Okay, so let's erase this. Okay, let's erase. Okay, so okay, minus 5 comes at the first index and my, okay, sorry, minus 5 comes at the 0th index and minus 3 goes to the first index. Okay, so now idx becomes 0. Okay, now let's look. Okay, so idx, now parent of 1 is 0 only, right? Parent of idx, this index, okay, which was 1 earlier, now idx becomes 0. Okay, so first condition is not satisfied, hence we do not check for second condition and this while loop terminates and hence the function do not execute. Okay, so this is what we are going to get. Okay, now to draw this, let's draw this. Okay, let's draw this here itself. So the heap we are going to get now is going to be something like this. Okay, this is the final heap after the decrease key operation. So minus 5 is at the top. Okay, then we have minus 3, 7, 9 and 5. Okay, now let's see the hierarchy. So minus 5, this is the smallest and it is smallest from the two childs. Okay, and minus 3 is also having a value smaller than the two childs of it. Okay, so this is a min heap, right? Min heap has the property that, you know, every node has a value smaller than its child. So yeah, this is how a decrease key function works. So let me, let me give an example. Let me take you to the Visual Studio Code and give you an example. The same example we'll work upon. Okay, so earlier what we passed minus 3, 5, 7, 9, 11. Okay, and what we should get, okay, let me write it somewhere. Okay, so that we know. Okay, so let me write it here. Okay, so the input is going to be something like this. Input is going to be something like this. Okay, so it is minus 3. Okay, here we haven't fixed the heap, right? Minus 3, 5, 7, 9, 11. And after calling the decrease key function, this function, what we are going to get as the output. Okay, output is going to be something like this: minus 5, minus 5, minus 3, 7, 9 and 5. Okay, let's check whether we are true or not. Okay, whether we are right or not. Okay, let's first implement the decrease key function. Okay, so let's create another function, decrease key.cpp. Okay, so this is going to be the program. Okay, sorry, doing something wrong here. Yeah, okay, why not I simply copy the value from this to this. Okay, now we are only going to implement the decrease key function. Okay, so okay, implementation of the decrease key, okay, function. Okay, so void decrease key, okay, int I, let's say index we give it as I. Okay, int value. Okay, now what we do, arr of I index becomes equals to value, right? Now we use while loop. While I does not equals to 0, while index does not become 0, and ARR of I uh, is somewhat less than ARR of parent of I, right? Parent of I. So what we do in that case, we swap ARR of I with ARR of parent of I, and I becomes equals to parent of I. Okay, so this was the function, right? Let's use it. Okay, so let's suppose, let's erase all of this. Okay, let's again create a heap. Okay, so heap, okay, this is heap min heap. Okay, because we are talking about min heap now, and let's say it has the size 5. Okay, so now what was the input was minus 3 5 7 9 11. Okay, okay, so m dot arr of 0, okay, equals to, now let's copy it. Okay, okay, so this is going to be one index, this is going to be two, this is going to be three, this is going to be four. Okay, now okay, so all these are not going to be m, rather they are going to be min heap, right? They are going to be min heap. Okay, so let's suppose this is the, you know, this is the heap, right? So at the index 0 we have minus 3, at index 1 we have 5, at index 2 we have 7, at index 3 we have 9, and at index 4 we have 11, and then we have changed the size of the heap to 5 because it should have size 5. It has 5 elements, right? So now the output that we should get is minus 5 minus 3 7 9 5 after calling the decrease key function by passing it this way, parameter this way. So we are going to pass index as 4, and we are going to pass its value as minus 5. Okay, so let's call the function now. Okay, so min underscore heap dot decrease key 4, at index 4 we are going to change the value as minus 5. Okay, now if we try to print it for int I equals to 0, I is less than min heap dot size. Okay, okay, I plus plus. Okay, we are trying to print all the elements of the min heap array. Okay, I, using the for loop. Okay, yeah, so simply what we should get our output as minus 5 3 minus 3 7 9 5. Okay, let's print the output. Okay, what error we are getting, I don't know, man. Let's, yeah, minus 5 minus 3 7 9 5. Okay, minus 5 minus 3 7 9 5. Yeah, so we are getting the correct output, right? This is how the heap becomes after changing the value, right? You can see minus 5 minus 3 7 9 5, and the indexes of these particular nodes will be I equals to 0, I equals to 1, I equals to 2, I equals to 3, and I equals to 4. So this is how a decrease key function works. Okay, so yeah, this was all about this lecture. Okay, so we talked about the changing the value, rather, decreasing it to a lower value, so that we can uh, simply use it to eliminate a particular node. Okay, we are going to look at the example of the decrease key function, which is very important. Okay, decrease key function is used along with a function called extract minimum in order to remove a particular value from the min heap. Okay, so let's suppose we want to remove this value. Okay, we don't want this value in the index. What we are going to do, we are going to decrease it. Okay, decrease it to the lowest. Okay, so that it comes at the top, and then we are going to extract, use the extract minimum function. And what extract minimum function will do, it will remove the minimum element of the min heap. Okay, so it will obviously remove the first element, and hence we are left with only 4 values that we want. Okay, other 4 values. Okay, so yeah, this is how the decrease key function works. Hope you would like the lecture, and hope to see you in the next lecture.